For this course, I will be using the Devastator tank chassis by DF Robot, an Arduino Uno, an Arduino motor shield, the Johnny 5 robotics framework, and of course, the beloved Xbox 360 controller. Now, before I dig into the code, I do want to go over a handful of things regarding the Devastator chassis I purchased for this project. I actually bought mine directly from the manufacturer's website, but only because it was much cheaper to do so at the time. Since then, I've seen other sites come down in price quite a bit, so I don't know that it will save you as much money these days by getting it directly from DF Robot's site. I also had to wait about 2 weeks for the thing to be delivered, so if you're wanting it sooner, you may want to look elsewhere for it. Ultimately, though, you can use whatever chassis you would like for this project. As long as your chassis has 2 motors mounted to it and you have some sort of motor driver attached to control them, you should be fine. Now, in terms of powering the tank, there are actually a couple of routes you can go. If you look at the assembly instructions, which you can access via the DF Robots product page, and then scrolling down to the document section here, hitting up Assembly Manual version 2, opening it up, and you can see I've actually opened this a couple times already. But if you scroll down here to the second to last page, I believe, there it is, you can see that you can use the included battery pack or a rechargeable LiPo battery. Now, I just used the included battery pack as I didn't have a spare LiPo battery lying around, but regardless of which way you go, you'll need to make sure you have some hookup wire available, these red and black wires here, as well as a female DC power plug adapter. In terms of the microcontroller, I just used a spare Arduino Uno R3 that I had lying around, and then purchased the Arduino motor shield to plug directly into that. I actually ran into a few challenges when mounting this setup, which I'll quickly point out here so that maybe you can avoid the same pitfalls. First off, I had to put in a couple of layers of standoffs to elevate the board enough, which you can see down here at the bottom. And this is because the battery pack was blocking the USB port otherwise. So I'll turn around here and show you what's going on there. Now, yes, I could turn the board around so that the port is facing the front of the chassis, but then I wouldn't be able to get the top plate on, which is lying over here on the side, because I wouldn't be able to have a clean way of plugging my USB cord in. Now, you may be thinking, well, yeah, sure, but just keep the top plate off initially, load your sketch onto the Arduino, unplug the USB cord, and then put the top plate back on. Bingo bango, problem solved. Except that won't work because the Johnny 5 framework that I'll be using in this course doesn't run directly on the Arduino itself. It actually runs on a host machine, my PC in this case, which needs to be tethered to the Arduino at all times so that it can send the microcontroller the appropriate commands. Now, I haven't experimented with this yet, but I do believe that Johnny 5 works over Bluetooth or Wi-Fi, so if I purchase a BLE or Wi-Fi shield, or purchase a new Arduino altogether with either or both of these things built in, then I should be able to operate the tank without the cord being plugged in at all times, and this should resolve my mounting issues. And speaking of mounting, there's actually a mounting hole in the Arduino and motor shield too, I guess, that is really close to the stacking headers, and I didn't have a small enough screw to be able to put in there, so I'm currently rocking just a 3-legged setup. The issue was that there wasn't enough room for the screw head as it bumped up against the header, so any screw I tried putting in there ended up being put in at an angle, which of course was less than ideal, so I just left that one out. Now, I use metal screws for my setup, but I've seen other people recommend nylon screws to prevent any shorts that could arise from the screws or nuts coming in contact with any of the components on the boards, but I haven't had any problems with the metal screws, so that's a decision you'll need to make. Now, since I just used a basic Arduino board without any bells and whistles, I had to purchase a motor shield, of course, to be able to actually drive the motors, and as I pointed out already, it plugs directly into the headers on top of the Arduino, as you can see here. This works just fine, but things are really tight when the top plate is attached. I'll kind of show you this here real quick. So it's kind of hard to see, but I mean, there's enough room for everything that I have now. But if I wanted to add a BLE or Wi-Fi shield to this setup, I wouldn't be able to put the top plate on because there just simply wouldn't be enough room to mount everything. Now, the top plate really isn't needed to be able to drive the tank, though it does stabilize the chassis quite a bit. But if I want to mount a camera or add some sensors down the road to maybe make my tank a little more autonomous, I really do need that top plate on here to be able to mount those components. So as you think through which board and shields you want to use for your setup, just keep these things in mind. Now, DF Robot actually makes their own Arduino-compatible microcontroller called Romeo with motor drivers built in. The company has a handful of different versions of this board, some made to work with the Intel Edison board, some with Bluetooth integrated, etc., etc., so take a look around before settling on the first one you see. Whenever I find some time to revamp my setup, and a few extra dollars, I think this is the route I'm going to go. Now in terms of wiring up the motors, I just used some basic 22 gauge hookup wire, as I pointed out earlier, and literally just hooked one end onto the motor and then attached it to the appropriate terminal on the motor shield. Now of course the wires are a little loose and could result in some bad connections, but I haven't had any issues with this setup yet. For a long-term solution though, I would definitely solder these wires to the mounting holes on the motors. And one last thing I want to point out is that the right side motor on my setup does not work very well, and I believe it's due to a faulty motor shield, as I've tried wiring both motors to each of the terminals, and whichever motor is wired up to the A terminal doesn't operate very well. So as I get into the demos, you may see that the right side doesn't respond very well at times, but you should still be able to get the gist of what I'm talking about. Well, I think that about covers the physical setup of the project, so without further ado, let's get into the code.